BJ, if you'd like to just start us out as you usually do, sitting in that corner, if we're to ask you to balance a redox reaction, what would step one of our explanation in a problem-solving process look like? Step one.
Write separate half reactions.
All right. I'm going to ask you to write down what I'm writing down so we have kind of a step-by-step process. Take this complete equation and turning it into half reactions. So write two separate half reactions. When I think about this basic solution, the hydroxide and the water are going to be involved in the final process when we're balancing. Remember, those are the tools that we use to balance. But I'm not going to include them actually in the first part of the half reaction. We'll end up placing them in anyway when we balance H's with water and hydrogen ions. So let's divide step one, CrOH3, CrOH taken 3 times, forming CrO4 minus 2. There's the first of our half reactions. Secondly, we'll go OCl negative and pointing at Cl negative. Step number 1 of my explanation, write the two separate half reactions. I'm going to draw a line to say that's the end of step number 1. And Nate, when you're ready, what is step number 2 in this multi-stepped problem-solving process?
For each half reaction, balance all reactants except H and O.
So balance everything but H's and O's. Thank you, sir. So I'm going to do a double check. Chromiums look good. Chlorines look good. Done. Perhaps we would have needed a coefficient, but in this particular reaction, the other elements other than the H's and O's were all set. Alrighty. Taylor, what would the third step of this multi-step journey look like? Alrighty, thank you. So balance the oxygens using water, or H2O if you'd prefer to write that. So I'm going to rewrite that first equation, CrOH taken 3 times, points at CrO4 minus 2. I need to count the oxygens in this step. I've got 3 oxygens on the left, 4 oxygens on the right. 1, 2, 3, 4, 3 on this side, so it looks to the left-hand side. I'm going to add a water molecule. 1, 2, 3, 4 oxygens, check. Down to the second half reaction. OCl negative went to Cl negative. Adding a water to the right-hand side balances the oxygens. So far I've added a water to the left on the first half and on the right on the second half. And that took care of step number 3. Draw a line. Claire, what does step 4 tell us to do? Okie doke. Balance H's with the proton hydrogen ion. Here's what we have so far. H2O plus CrOH taken 3 times, going to CrO4 minus 2. There are 3, 4, 5 hydrogens on the left-hand side. So I'm going to place 5 hydrogen ions to the right-hand side, balancing the H's. To the second half reaction. So far I have OCl negative, pointing at Cl negative and 1 water. To balance the H's, there's 2 on the right. I'll add 2 hydrogen ions. 2 H's, 1 O, 1 O, 1 Cl. Draw a line. We're done with step 4. Nicole, what is our 5th step in this multi-step process? Alrighty, so balance the charges using electrons. To the first half reaction, rewriting what we have. I'm going to count the total charge, what we have so far. 5 positives, 2 negatives. The right-hand side of my first half reaction looks so far like a +3. And on the left-hand side, I'm seeing so far the charge to just be a neutral 0. To the more positive side, I'm going to add 3 electrons. When I add 3 electrons, I've changed the charge from a +3 down to a 0. Same strategy, the second half reaction. So far, I had 2 positive hydrogens with an OCl negative pointing at Cl negative and a water. The right-hand side so far is at a -1. The left-hand side, let's see, a +2 and a -1 gets me a +1 overall. The more positive side is the left side. I've got to bring it down to match the -1, so it looks like 2 electrons will be added to the left-hand side. Depending on how big you write, I'm going to grab another sheet of paper. You may flip over, but to do mine, I'm going to keep that up there. Hey, Nate, we're on step number 6. Thank you. So multiply the half reactions. And I always just write it this way to make sure Leo equals Gur. The number of electrons lost will be equal to the number of electrons gained. Leo must equal Gur. So I'll rewrite what we have so far. Thinking about up here, I just have it written. If 3 electrons were lost and 2 were gained, what we'll end up doing is distributing a 3 in the second half reaction and a 2 in that first half reaction. We have to turn those both into 6 electrons gained, 6 electrons lost. So if I think about just showing that, I'll distribute. I'm going to take a 2 and distribute through the first half, and a 3 and distribute through the second half, and I'll rewrite by multiplying at that same time. So I'm going to distribute the first half reaction. 2 waters plus 2 CrOH3 yields 2 CrO4 minus 2, 10 hydrogen ions, and 6 electrons. I'm going to distribute a 3 through the second half reaction. So I have 6 electrons, 3 times 2 is 6 hydrogen ions, 3 OCl negatives, 3 Cl negatives on the product side, and 3 waters. So step number 6, make Leo equal Gur, and we did so by distributing. The number of electrons lost now is 6, the number of gained is 6. We have indeed made Leo equal Gur. McKenna, I'll draw a line. Would you share what step 7 asks us to do? Alrighty, thank you. Add back together. Simplifying anything that we can along the way. So if I think about what might cancel, I can definitely see the electrons canceling. They're gone. I can see on one side of the arrow I have 2 waters, and on the other side of the arrow I have 3 waters. I'm going to remove all 2 waters, leaving me a net 1. On one side of the arrow I have 6 protons, on the other there's 10. Let's simplify to leave a net 4 and add together. So what's left? So far I have on the left side of my arrow 2 CrOH3s plus 3 OCl negatives. On the right hand side, 2 CrO4 minus 2s